What's up, robot builders? So today what we wanted to do was try a kind of a little bit different format, and what we're going to do is just build a LittleArm Big, because we realized we don't have an assembly tutorial out there for that yet in video format, and it's just a way to try a different type of video, kind of a live stream style video. So there's going to be a little bit longer, probably about an hour long video. So let's get started. Right here we've got all the pieces for the LittleArm Big. We've got the servos, we've got the main chips, a few little added accessories for the edges and pieces and everything else, and then the main 3D printed pieces. You've got the control box, main base, shoulder, upper arm, elbow joint, elbow cuff, wrist end, wrist yoke, and then the gripper and everything else. A couple more servos and so on and so forth. To get this assembled, all you need are a standard Phillips head screwdriver, kind of a finer point is always good, and a hot glue gun. And that'll be pretty much all that you need to get this done. So let's just go ahead and get started here. What I like to do, let's start with the base here. What I like to do is get the suckers put into the base, because it's a little bit harder, but it's also just a really easy thing to do because it takes no thought at all. Go ahead. You take the sucker, and on the side of the sucker you've got a little square slot in there so that this head can kind of squish a little bit. On the bottom of the main base itself, you've got two little notches on either side of the hole. Line it up so that the square is parallel with those notches, and then you can just press it in there. Generally, kind of smoosh it up. That'll pop right through. You might need a pair of pliers. A pair of pliers is always good because then you can just pull it through, but there's a danger of hurting the suction cup there. Take this just like that. Two down. Make that all even. Okay. This must be riveting video. Yeah. So with the LittleArm Big, what we had created with this was really to create a robot arm that was still fairly easy to put together, but had enough complexity within it that you could do more advanced robotics control with it. Now it uses hobby servos, which they don't have the precision that you really need to do high quality inverse or forward kinematics, and it's kind of dependent on how you assemble it and where you line up the joints and everything else. But overall, the LittleArm Big is viable for that stuff, to give you kind of a rough idea. So there we go, there's the sucker. Yeah. So now what I want to do is then I go on to the upper arm, and the upper arm, you've got two slots for the servos right there. We're going to use these large metal geared servos. All the servos on the LittleArm Big are metal geared. All the servos on all LittleBots are metal geared, except for the continuous rotation ones. Feed through the wire on one end, and plop the servo right into there, just like that. Sometimes this upper arm could be a little bit tighter, but in that case, still, just press the servo in there, and you'll be fine. Feed through this other side. This makes a really nice single package, though, for both of these servos. Now, in some of the older written tutorials, we have these two servos set as being screwed in after you do this. They've got 4 screws right there, and you've got the screw pack right here. But the thing is, that's not necessary. Since both of these servos plop into these elbows like this, there's no way for that servo to ever fall out unless the whole arm was disassembled. And in that case, you kind of want it to be able to pull out, so you can disassemble the arm and replace the servo if for some reason you strained the arm and you stripped out the servo or something along those lines. So don't worry about it. Don't use screws on these. It's really not necessary. On the side, you've got the large nub and the small nub. The small nub is the top of the arm because it's connecting to the smaller elbow. Take the servo wire here, get it all straightened out and even, and just feed it through there. That'll make that clean and simple and easy. Okay, there we go. So now the upper arm is all prepped. Let's see here, going on to the next thing. I'm going to do the cuff. I like doing all of these really easy servos that are easy to plug in first because it's just easy to get started. Small goals to get yourself started. This time you want the small MG90S metal geared servos. These are the small ones that are used on the 2C. In fact, interesting fact for you here, this cuff and actually kind of the wrist assembly of the LittleArm Big are based very heavily off of the shoulder and elbow assembly of the LittleArm 2C. With this servo, it plugs right down there into the bottom of the slot. You do want to screw this one in, because if it pulls out, then your whole gripper is going to fall off. So go ahead and get your screw pack out here, and there'll be two little tapped flange screws in there. Little small guys. Standard servo mounting screws. Just stick them in there and screw the servo down. You don't have to go tight, just firm. Get it down there so that everything contacts, but don't go reefing on it, because there's no big stresses anywhere on this arm where a screw needs to hold on for dear life or the arm will fall apart. None of that exists anywhere. So just make sure that everything is firm but not overly tight. This thing right here goes like that. Okay. Let's see here. I am going to, let's grab this one here. Let me clear that out a little bit. There we go. So now the shoulder piece. Again, this is basically the 2C shoulder, almost the exact same part. We're going to go ahead and get a half servo horn there, and you're going to plug that right into the top of the shoulder. And it should set right in there. Make sure that it goes in all the way, because you're really going to need that moving forward here. Let's see here. Okay, that's pretty good. Now, with the servo, go ahead and find another horn, put it on there, and manually, but gently, please be gentle with this. If you go reefing servos back and forth like this, it's not good on the servos. Most of them can take it, but it can result in you hurting the servo, because you can strip out the gears, or you can create a back EMF that can burn out the servo, and none of that stuff is good. So very gently rotate this servo clockwise until you hit the end. If you hit the end, kind of back off a little bit and try to hit it again, just to make sure that something just didn't jam. Okay, take that, and then go ahead, take the shoulder, and there's a little arrow on the top of the servo facing forward. Have that facing almost 90 degrees, or fairly close to 90 degrees. Oh, that's not very close at all. Right about there. Right about 90 degrees right there. And then you're going to take the horn mounting screw, which is a small, stubby little screw in your servo kit, and screw it on there. And again, this one, don't go super tight, just go firm and kind of test your shoulder. You should feel not really wobble, but a looseness to it, so that the shoulder is able to move smoothly. I actually have a small servo testing rig over here. Let's put that up here. So this is just some potentiometers on an Arduino Uno, just so we can test servos really easily. Plug that in there. That's moving pretty well. Let's try this one. There we go. So we got pretty good motion there. It's doing what you would expect. And it's within the realm. So yeah, got that pretty close. Nice. Let's set that off to the side again. Nifty little tool for testing servos there, but anyhow. Okay, so the next thing, that's that main kind of nodule there. I'm going to take this one, take the gripper palm, get yourself another small servo here. And then it plugs right into the side of the pump. You take this, just wham-a-doodle. Wham-a-doodle, that's a good word. We're going to come up with all kinds of new words today for describing how you're getting your stuff done. Wham-a-doodle. Wham-a-doodle. There we go. So that servo is in there. Just make sure it's set so that everything's square and pressed in as far as it can go. This servo, again, doesn't use any screws. We don't like screws on the little bots if we can avoid them at all. Most of the time, if we do use screws, they're actually kind of just a safety mechanism. Okay, so there is that. This arm, this palm, has a little notch back here. It's for this wire, and it's for this wire to clear the gripper. So I'm actually going to take that, and the way you get this done is you got to use your hot glue gun, put a dab of hot glue in there, and then set your wire. So I'm going to do that right here. Dab of hot glue, and then set your wire. And this will just make sure that the wire is out of the way. In order to kind of contain it from the top, I'm going to put a little more on the top there, and that'll be good. You know, hot glue you always kind of think as a fast-setting glue, but you know, when it's really hot, it can take a long time for it to actually cool down and solidify. But the main gripper, the gripper itself, is the LittleBots gripper. We use this gripper across a whole mess of the LittleBots. So the LittleArm Big uses this gripper, the LittleBot Original uses this gripper, and the LittleBot Budget uses this gripper. And it just mounts on the front there. So we have a common connecting system for all of these so that we can take the gripper off of one bot and shove it onto the next and get some more use out of it. It's also just a really nifty gripper because it's clean. It's only 4 pieces if you count the servo there. And you can run around and grip stuff. It's very light, so you can put it on all kinds of different robots. And it's pretty easy to work with there. Okay, so now I'm going to take the idler finger, which is right here. Clean. I see some fuzzles there. Fuzzles, there's another new word for you. Fuzzles. A strand of filament protruding from the side of a part. Make sure that the idler is free and loose, and then you're going to take your main drive servo finger, and you're going to make sure that it lines up with the idler so that when you deactivate all this or put all this together, the gears mesh and they are even. And this can be a little bit tough. Sometimes it takes a couple of tries because you just misestimate where it goes. See, like what I did just right there. That's not where you want the gear. So I'm about 1 tooth off. Let me see, pop off the bottom. Yeah, you want to go onto the servo first, and then you go onto the bottom with the rest of it there. Okay, 1, 2. You do want to be a little bit careful with this, because if everything's, you can break off the gear. So just be kind of gentle with that and cogent. Don't go trying to ram it on there, because you can break stuff. So there we go. Now we're going to take the wrist end, and we're going to stick it in here, just like... Actually, I need to double check myself on this one, because I might forget how it all went together. Okay, so you want the idling side of the gripper up, and then the wire meshing side of the wrist end down. Just like that, see? Let me double check. We've got an arm over here for me to reference in case I ever forget. Oh, I already messed up. You want the wire side of this thing up and the idler side of this up. So, and then you just put it on the side there, slide them together. And because of the layering of the 3D printing, these two parts basically lock together, and now you've got your gripper there. And that's how she goes. Now the gripper's all set. I'm going to put the servo into the side of this idler end here. Plastic bags all over the place for holding this stuff together. Okay, feed the wire through the end there, and then put in the servo. The servos can be a little bit tight going into this idler or this wrist end part. So I like to remove the stickers from the side of the servo because it is that tight of a tolerance. The stickers can also sometimes curl up inside of there and cause the servo to jam, so it's really hard to get in and then get out. So it's best to remove the stickers. If for some reason your servo is a little bit loose, which is hardly ever happens, then you want to have the stickers on there, but you won't need to. And press that in there. It can be a little bit firm. There we are. Take it up to the side of the table sometimes, and this is a good alternative to pliers or hammers. You don't want to hit servos on the end. Don't bang any servos on the end like this with a hammer, please, because that does really hurt them, especially if you don't have much feel for it, if you're new to it all. Just edge it in there. And this is kind of the same. I want to reference this one on the LittleArm 2C too, because the LittleArm 2C has servos similar to this, and it can be tougher to shove them in there because they go in tight. We want them to go in tight. We want them to be firm and reliable inside of this arm. So you got to just be careful and patient and edge it in there, and then you've got a nice, tight, well set servo. And there we go. So there's the whole wrist end all ready to go there. I'm going to go ahead and feed this wire through the end here. So we got that cleaned up. See? A couple of fuzzles slowing it down. There we go. Feed that through right there, make sure everything's clean, and there's the whole gripper assembly. That looks pretty darn slick. Okay, now I'm going to mount this gripper here onto the end of our actual arm. And there's no way to really get this wrong. Take the servo armature sticking out there, put it through the hole of the shoulder piece or the wrist yoke, and plop it in there. And there we go, that's latched in there. Now we're going to go ahead and put the horn on right there so that it's refined. For this one, actually, I'm kind of cheating here because we've got the servo driver rig over here. Prior to doing this, what you want to do is have the wrist so that when the servo is fully rotated this direction, the arm is down here. So you would manually, before you put the arm in here, rotate the servo all the way in one direction, and then mount the arm so that, and put on the servo horn so that when the arm is down here, the servo is fully extended. So, I'm going to try to demonstrate that a little bit more here. Get the driver over here. Plug it in. Oops, grabbed the wrong one. Wrong servo. There we go. This is the one I want. Plug it in here. Yeah, so turn the servo all the way to the end to where it would be if it was moving the arm. And then move the arm to basically 90 degrees because we want some slop and we want it to be able to move in both directions an equal amount. And then just shove this horn in there. Up, on, over the horn. There we go. Once the horn kind of gets into the slot, it can be a little bit tougher to mesh it with the servo because you're touching around and you're trying to make everything go the way you want. Okay, so I've got the horn there over the top. There we go. So that's the full range of motion of the gripper. And then, if I plug in the wrist here, I should be able to see them both moving in all their glory. There we are. We've got a dismembered hand that we can control here. That shaking, that kind of bump up and down is not me. Just it's the servo signal, and if it's sending something that's a little bit odd, it'll get that. Once we've got it the correct software, full software running on it, it won't be a problem anymore. Okay, so now I'm gonna get all this straightened out just a little bit. Again, when you're rotating the joints, try to be slow and gentle so you don't ram everything and have it all go bad on you, because the servos can be damaged by manipulating them. So I want to make sure that's really clear. Because people have problems with it sometimes. Man, you wouldn't think it'd be that, oh no, not a puzzle. That's not a puzzle. We're fine. I'm just not competent. So go ahead and run the wires through the edge of the cuff here, one way or t'other. So run these wires through, shove them through if you're not able to push them through with just the wires themselves. Leave a little bit of slack right there because again, this arm is rotating down and up, so you want this bow of wires so that they have the room to move where they need to move. Now, the next part we're going to do is probably the trickiest part to do of building the LittleArm Big. Let's move over to the side. And it's meshing these two pieces, the elbow and the cuff. And this can be, you can't hold on to stuff. So the main elbow and the cuff, you've got to align these two holes so that the wire can run through the elbow, while at the same time trying to keep everything as circular and correct as you can. What we're going to do is we're going to, first of all, thread the wires through here so they're not in the way while we're doing this. But then you have to run a piece of hot glue through this little channel on the bottom of each part and then press them together. And make sure as much of it is straight as is possible. If that's not straight, then you need to pry the thing off and put it back on, and that's tougher to do with hot glue. So I don't want to put pressure on you, but try to get it right on the first try. Make sure that you're positioned and everything is ready to go on the first try. I forgot to put in the screw on the wrist cuff, the wrist grip there. Okay, so got our hot glue gun. Clearing out all the stuff, make sure your workspace is clear. Move all that stuff over the side. So, take the cuff, bring it up to right there. Make sure everything's going to be pretty. Take those wires, hold them down out of your road, and I like to just hinge that elbow right there. Then, it's not going to be a big bead of hot glue. You're just going to kind of barely fill that in, because again, it doesn't take much to stick all this stuff together. So, take your hot glue gun, run a light bead along there, just kind of fill out that channel, and then you go wham-a-doodle. Kind of check it all really quick while the hot glue is still setting. There we go. And now that elbow is set there. Again, you want to make sure that your hot glue is pretty darn hot when you do this, because as soon as you contact it with the plastic, it starts cooling. If you've got it hot, you have the ability to ply and move it around a little bit without having any kind of problems. Now, it'd be great if this cuff and this elbow had like a single pin going through them that could get them straightened out. We don't like pins because, number one, it's an extra piece. Number two, they're not reliable themselves, so you would still have to use the hot glue gun. And having a protrusion coming out of either end of these pieces, both of these pieces, we just combined their bases. So that's the part that's against the printer bed. So you don't want a pin sticking out the bottom of it, because then you've got to support everything and it's a big mess. If you have any kind of suggestions on how to swap out this design and improve it, we're happy to hear it. We love to hear any kind of suggestions that people can come up with if they're good for the manufacturability and for the usability of it, because this is a tougher part to put together, but this is a tougher kit as a whole to put together. I mean, this isn't a 5-year-old kit, this is a high school, college level kit, so I hope you can handle a hot glue gun, and if you mess up, you can handle dealing with the mess up there. Okay, so there's that. Now, the next step is combining that with the upper arm here, and we're just going to start going down the line with all this stuff, slowly combining everything. Now, this one, exactly the same as the process we went through before. Put the armature through the edge there, and then slop it in. There we go. So there's that. And again, I'm going to use my nifty homemade... Man, this thing looks really old, guys. we could probably invest in a slightly fancier looking rig than a board with an Uno attached to it. Let's see here. Plug that in there. Gonna go ahead. There we are. Again, move the servo so it's all the way down, and then set this at 90 degrees and try to attach the circular servo horn there. It's not really a horn. What's the circular one called? A hub? I mean, all the other ones are horns, but that one's not really technically a hub, is it? It's not, or not technically a horn, is it? I don't know. Anyway, set up this horn. It's got four batches of four sets of 3 holes all the way around. You want those holes to be a square that this thing is perpendicular along. So try to press that in there as close to square as you can, because that's going to help it align with the holes. Then the servo was set up in a position where we like it. Just wobble stuff around there a little bit. And then, let's see here with it. There we go. There we go. Actually, I'm going to readjust something a little bit here. This one's kind of a touch because you want the servo's home position, the place where we just put it, where the servo's all the way down like this, so that if the arm's attached, the arm's all the way down and sitting at 90 degrees like that. I'm a couple degrees off, and that bothers me, so I'm going to fix that. There we are. There we go. Okay, so now there are 4 holes in this hub here. You only need 2 of them. The other ones are a guilty pleasure if you are a hole maniac. So mainly just do the ones on the gripper side and on the opposite side of the gripper side, because that's all you need. Oh, wait, before I do that, make sure that you screw on the horn first, otherwise it's going to be really hard to put in those 2 other mounting screws. Put in this gripper here, again, make sure it's down firmly, but don't go reefing on it. Don't go reefing on it. It doesn't deserve that kind of abuse. It's all right. Just let it be. This elbow can actually get away with just 1 screw. So again, multiple screws, kind of a guilty pleasure if you're just obsessed with screws. So there we go. That's how it should be. This arm can be down a little bit lower if you really want to, but that servo has some extra slop beyond that makes up for that. While you're controlling the servo, it will only move down to that position. So actually, let's just plug that in right now. Let's see how it looks. So, with that, there we are. And back down. Right there. Perfect. That's great. Again, and one more comment on this. If you have a preference, if your particular application or use of this arm needs more room, go ahead and unscrew the screws and move it down 1 hole or something and slide it along this horn. You don't have to disassemble everything. Just undo that 1 or 2 screws there and just move it down. It's fairly simple to address that issue. Alright, put in a second screw here. I dropped my screwdriver. Always great when you lose that. It looks so professional when you lose your screwdriver. Oh, one note on these servo horn screws, the small tapping screws that we're using to mount this elbow right now, these 2 silver ones, they are not the ones that come natively with the large servo horns. These screws, the ones that come with the large servos, are too big. So there's an extra pack of small tapping screws included in each kit, where there are the smaller versions of these. You want to use the smaller versions of these on this elbow, otherwise you're going to go all the way through and jam with the servo and everything else, and it just causes lots of problems. So don't do that. Okay, now we want to clean up all of these things and get them into a position where we can assemble them. So go ahead and get your servo extensions, plug them onto the end, start plugging them on the ends here. Again, white goes with white goes with orange or yellow, depending on your color, and then black goes with brown, and red is with red. So middle is middle. There's no way to really mess that one up. And then grab another one here. Move all this out of the way. I don't think we'll need that again for a little bit. Plug these on here. Make sure they are plugged on all the way, because if you don't plug these together well enough so that they're well meshed and everything else, you may end up with an issue where it comes unplugged inside of the robot arm, and then you're like, oh, the servo's broken, and it's really not. But it takes a lot of troubleshooting to find that problem. So now we want all of these wires to be going through this deal. And in order to get that done, we're basically going to move up this line of this. So we're going to start with this wire, and then this wire, and then this wire. So because that will just leave everything as clear as can be for everything coming after it. So the first one's going to go easy because got lots and lots of open space in there. But as more wires get shoved into there, that's going to get tougher and tougher to find that open space. Let's see here. Again, leave kind of a little bow, a little slop up here for all that stuff to make sure that you have the clearance that you need. number 2, or number 3, I guess, technically. I don't really count that first one, because it wasn't hard. There we are, and last one. Oh. I can buy that one. Oh, I forgot what I needed to do. With the number 2 here, don't shove that in all the way just yet. Put this one in next, and then shove that one in all the way. There's a sequence of operations with these to make sure that it's as easy as possible to put together. Otherwise, you'll just be fighting with stuff that you don't have to fight with. And with this connector, just shove it in about that far, and make sure all the other wires are parallel with it, just like that. When you're jerking on them, make sure you don't jerk them out. And there we go. There's that little bow. Well, get that bow up there, that bow right there, and there we go. So now we've got the upper arm all finished. All the wires are ready to be released. Now we're going to feed that through the shoulder. We got the shoulder part right here. Feed these through the top of the shoulder, the main hole there, just like this. That's just falling down the end of my nose. That's a good look. Look like an old man. It's like, yes, here we go. Put this together here, and we'll see how this robot continues to operate. That's a good. There we go. Go ahead and press in the wire in first, and then plug that in. There's the servo. It's all the way in. Go ahead and grab the large servo mounting screws now, and that thing is bugging me. There we go. Actually, we might address that thing next. Alright. Screw these in. Use the star pattern, as in upper left, lower right, upper right, lower left. In that pattern there. Actually, I'll show that here in just a moment because people will be confused. 1, 2, 3, 4, just like that. And you don't even have to go all 4. Again, the screws are all overkill. So you can get away with 2 screws on this base servo. We're going to use 4 because we can, but they're really not necessary. And again, just firm. Don't go super tight, otherwise you'll strip stuff out, and then you will be in a problem, and you might be required to just use 2 then. Because these screws are just there to hold stuff together a little bit. Most of these things are press fits, like that small servo up at the top. They're just press them in there, and then you're good to go. And everything else holds it together. There's just no way to do that with these cuffs because we haven't thought of a good mechanism that's holds in that direction when you're trying to rotate around stuff. If somebody has any good ideas, let us know. We'd love to see them because we're always looking for ways to get rid of screws in these kind of operations. So now that servo is set up in the base there, we are going to leave it right there. Again, grab a large servo horn, put it on there, and again, gently rotate it fully counterclockwise, or clockwise. So that feels about right. Again, if you hit the end, kind of back off and then whack it again, just to make sure that you hit the end and you didn't just jam up or catch on something. So now that's rotated fully counterclockwise. It's ready to have stuff mounted onto it. We're going to take the shoulder here, and actually this is probably something I should have done before, but take one of the dual pronged horns, and plug it into the bottom of the shoulder, just like that. Set it with a couple of screws. Some of the small servo screws again, so that it'll stay in there. There we go. Make sure that's in there firmly. Get the second one. Do the other side. There we go. This is a long video, And like half of it must be me screwing in these screws here. I don't know what kind of color commentary I can do on this. The screw was invented about 1,500 years ago as a way of containing water wheels or something. I don't know. There's no extra explanation I can do for screws. Screws are stupid. Screws are like the dumbest thing ever, because screws are generally indicative of, personally I believe, of lazy design. Because a screw is a fastener that works anywhere, so everybody uses it all the time for everything, as opposed to using better systems like sliders or latches or some kind of plug together systems. That's personal opinion. I really hate screws, so we try to avoid them. So now the horn is arranged at the bottom of the shoulder there. So let's see here. We've got the base all set up. That's good to go. So now we're going to go ahead, add on one more extension wire here. Plug that onto the bottom of that one. And we're going to get all these fed through the base. Well, let's start with that one because it's easy. And two feeding wires. That must be the other thing that's just about as fascinating as putting screws in, is me feeding wires through a hole here. Get these all going out the back of the base. Ultimately, though, the LittleArm Big is actually, or any robot arm, is actually a really simple mechanism, because it's just a bunch of motors on the end of sticks. That's literally all any robot arm is. Some get a little more complex in the design. I mean, you have the octopus-style arms, the ones inspired by elephant trunks and that kind of thing, which are all really fascinating engineering systems. But the standard robot design, robot arm, is based off of this arm, and our arm is not terribly interesting in a lot of contexts. The actuators themselves are, our muscles are fascinating, but how they're working is not that interesting. It's very, very simple physics. Okay, so all the wires are run out the back. We're going to go ahead and get the shoulder attached. Now, we had rotated the servo all the way clockwise, so now we're going to have the shoulder be positioned all the way clockwise. And so we're going to have it face to the right. And again, almost 90 degrees, maybe a little bit less, and plug it in there. And kind of feel it, see how we're doing there. It feels like we've got something sort of sticking. So I'm going to check the side here and see if there's something off. I don't think so. I think we're getting by all right. Right there. Plug that into the top. Look around the outer edge, see if there's something that's hanging that might cause a problem of some kind. And if the servo wasn't pressed in very much, sometimes you can shift just a fraction of a millimeter in one direction or the other, and that can eliminate any kind of catching that might occur or could potentially occur. Take a servo horn mounting screw with a large mounting screw, the black ones. Put it on there loosely for now, and then kind of test the spin there. Oh, that feels pretty good. That feels pretty darn good. I'm also going to test it with the servo. If you can actually actuate this stuff, you might actually assemble the circuit kit first, get it connected, get the Bluetooth app up so that you can test each one of your servos, and then you can have the app right here sliding. We should have done that with this, guys. But yeah, have the app connected first, and then connect each servo to the chip. And I'll kind of explain that more as we get to that. But the base servo right here, you can tell because it's the extra long one. I'm going to plug that in. That's not what I want. Well, that's not right at all. So I really messed up the connection there. I got the servo readjusted someplace. Let me undo that. Turn it all the way to the right. There we go. Right here. There we are. Put that back on. That's why you want to check and test things all the time. Always test everything, because you all always screw up something that you thought that you hadn't. Okay. That's pretty good. It's a little bit stiff, so that's perfectly forward. Okay, I'm going to unplug that right there. Now you want to, I'm going to take this off because it feels like it's kind of, the wires are getting jammed up in there, and that makes sense because right now there's no slack in there. I'm going to take this off. Yeah, there we go. Just make sure everything's clear and try to create kind of another bow or a loop in there like we did with the elbow and the shoulder before. And that will just reduce the opportunity for things to go wrong. And then shove them over to the side there and take some slack from up top. You're trying to create a system in there by which it's really easy for this thing to turn left and right. And this is this organization of the wires is not trivial. It's something that you might have to test with. So yeah, really have this servo connected to some way to control it to make sure that you're getting it set up correctly. Let's try that one more time. I think that's pretty good right there. There we go. That's sounding smoother. Very nice. I'm very pleased with that. Pretty darn pleased. Okay, there we go. Again, I'm going to kind of shove those wires through, give it some more slack inside of there, and now the shoulder's ready to be mounted. And the shoulder, get this elbow straightened out here, so we've got slack. Again, armature first, and then twist it down in there. If you want to be fancy, you can get like a screwdriver, and then you can pry it in there and back out and forward and backward and everything else. I can usually get it done by hand. There we are. So there, now the arm's in there. Oh, dang it. I forgot to preset the servo again. Before you put the arm in there, get a large servo horn, mount it on there so the arm's sticking out this direction, and then twist that horn all the way out as if you were pushing the arm down. That way, when the arm's in this position, you can take a servo horn and plop it on there. Since I forgot to do that, I'm not going to pull this out again. I'm simply going to grab this wire, and I'm going to preset it there electronically because I want to check it anyhow. So here we go, right there. Plug that in, and there we go. Alright, now with the shoulder, I like to go a little bit above horizontal, so right about at this angle, about 10 degrees or so above horizontal. Again, because this is kind of a limiting factor to prevent the arm from just slopping into the ground all the time. If you want to make everything go even higher and kind of, if you're building this for a classroom setting, I would actually take this up maybe even a little bit more. Well, not a whole lot more, but a little bit more. And that will make sure that the kids can't ram it into the ground quite as easily if you're dealing with younger kids there. Okay, so there's that. Plugged in, happy. I'm going to go ahead and set those screws, get myself some more of the small mounting screws here. Let's grab those right here and put them in on the side. And sorry, I'm blocking the camera, I know it. Okay, there we go. You want it on the top. I couldn't see where the holes were. I still can't see where the holes are. I'm going to turn it around here and I'm going to hide what I'm working on. I'm sorry. But put those two main screws in the bottom. Oh, I forgot the main horn screw there. There we go. There we go. Main horn screw. Put that on there. That should be set now. Oh, and actually, I forgot again. In the written instructions again, they say mount this horn there with 2 screws. no reason to do that, because the arm can't slide back and forth in there at all, really. I mean, if you really want to tighten it down so there's no lateral movement, you can, but the horn's not going to pop out. You're not going to lose contact in any kind of way, and there's no slop in this direction beyond what the servo normally has. I'm going to put one in there just kind of for good measure, but they are not necessary. So don't get bent out of shape about it. If you come up to that, ooh, look at that move. That's really nice. Let me get out of frame. Get out of the way. Stop blocking the object of attention. You'd think somebody who'd done videos before would kind of have to know that. Yeah. So, get this screwed in here. I am going to use the screws for the sake of continuity and consistency, I suppose, but they are not necessary for a basic assembly of this thing. They're quite redundant in the context of it. And again, like I said, I don't like screws. Screws shouldn't be in anything. The fact that they are necessary for so much is very irritating, because I mean, you think of like the laser cut kits. The laser cut robotics kits are fine because they're a cheap way to get a lot of variations out. But my goodness, you've got 200 fasteners inside of those things, and if you lose one, then the whole kit doesn't work. So it's really irritating in that context. All right, now the arm is pretty much assembled. I mean, we still got to set the gripper, but that's not a big deal. Got a nice flourish right there, nice flourish right there, nice flourish right there, so everything's good to go. Now we can do the electronics. So we're going to take the main board here, set those off the side a little bit. Pull out the MePad board. You'll have the Bluetooth module, and then you'll have the main Arduino board that has the Arduino Nano on top of it, and then the MePad LittleBots board, which has all of the analog inputs over here, and then the servo outs right here. We've got the Bluetooth in right there, main power, and then you've got a number of different expansions, including Wi-Fi, digital IR, and ultrasonic. So if you wanted to set up triggers for this arm to set up some kind of a pre-programmed sequence to create an actual assembly line with these, it's very simple to do because you have trigger inputs on this board. We're going to go ahead, set this into there. Falls right in, make it look nice. You're going to find, use more of those extra small flanged tapping screws. Put them in. Before you do this, do upload the LittleArm Big code first. It's on the website, on the downloads page, the LittleBots website. Get that going and get it uploaded. We already uploaded this beforehand. The board does not come preloaded with the software. So make sure that you open up the LittleArm Big sketch from the LittleArm Arduino, or LittleArmRobot.com, ArduinoRobotKits.com, and upload that sketch. Once we've got that going, we'll be ready and good to go. So it's plugged in there well. Get rid of that. Clear out some of this stuff. Once you've got that, take your lid. Make sure that it is fed face forward through all these wires again. And don't worry about the length of these wires. We're going to address that here in just a moment. It's very, very easy to do. We're going to add one more extension. There we go. There's that. With the Bluetooth module, in order for it to fit in here well, you'll need to bend these leads just a little bit. Take a pair of pliers, bend them just like that. Don't bend them too far. They don't have to go super far. You just want them straight, and then you can plug it on there very easily. But we're going to hold off on that for just a second, and we're good to go. So with all of these wires, we've got all of these extra lengths here, and we want them to match up a little bit. So there's a short 10 centimeter connector here. We're going to use that and connect it to the base connector, just like that. So now we've got everything lined out so that it's good to go, and we can run this deal and start assembling the electronics and start controlling it. So here on the servo connectors, I'm going to have us throw up the actual wiring diagram here. But you're going to go from base to gripper down the line here. In here, the pins are labeled, so make sure that white or orange is on the signal pin, and the other two are positive and negative. Red is positive, black is negative. In order to identify these wires, you go by length. So the longest, in this case, the longest one, original one, is going to be base and then shoulder and so on and so forth, because as you move up the arm, the end sticking out is going to be shorter. But once we add on these really long extra connectors, that gets all messed up. So try to go off of the orange. So with that, the first one, well, this is the longest orange, so that's the base. We're going to go up to the next longest orange. So here's the next longest orange. That's going to be the shoulder. So we're going to take the shoulder right here, plug it in right there. Now, of these three remaining, the longest one is going to be the one with the orange sticking out the most. So this one's going to be the elbow, most likely. If you reran your wires in there really weirdly, these things might not be as blatant if you've got like a lot of slack coming out somewhere. Next longest is going to be cuffed rotation. And then the next longest is going to be the wrist flexure. Right there. Plug that in. And then the very last will be the gripper. And again, like I said before, you might want to get all this stuff connected first. We'll get those things assembled, or loosely connected and assembled in their modules, and then connect to these. That way you can control them and calibrate the modules like I was doing with the control board, the driver board earlier. Get all these kind of lined out straight there, and then I like to take this loose loop and just bend it over for now, and then we're going to distribute them inside of the main board here. There we are. So that they're all out of the road and looking nice and everything else. Make sure they don't hit the reset button on the Arduino board, because that would be bad. Okay. So now we've got the arm loosely assembled. We're going to go ahead and take your power module, plug it in, give us some juice. Make sure that you've got your Bluetooth connection going, unless you're using USB. If you're going to control this via USB, make sure that this is not plugged in, because the two interfere with each other. They use the same USB serial channel on the Arduino Nano. So they can't overlap, otherwise they'll interfere with each other. Okay, so there's that. I'm going to get my app out here and ready to go. Open up. There we go. This is an Android tablet. The LittleArm Big is not supported on iOS. Go into, I'm going to see if I can turn around so you guys can see this at all. I'm going to go into settings. Make sure that my Bluetooth is turned on. It's currently not. There we go. Now, we can power this up. When you do the first power up, make sure that the arm is roughly in this position, because this is the home position of the LittleArm Big. And if you got it slapped down on the ground, then it's going to jerk up into the home position. You don't want to whack anybody, and you want to make sure that it's clear and can move freely, so it doesn't run into anything and you damage the servos if it runs into something and can't move there. Here at the first power up. So let's go ahead and get that going. Just like that. So there we are. That's roughly the home position there. I'm going to go ahead and search for Bluetooth devices. And you'll see a weird IP address that goes on and on, a whole bunch of numbers that look random, but they are the address of this Bluetooth module there. Password is 1234, because that's the default of all of these devices. We're pairing up. Good. Now, I'm going to go to the LittleArm Big app, get that to open up. This is an older version of it. we couldn't get the recent version on this pad. Connect Bluetooth very first thing. Make sure you get that. Select the module that works. It'll say Bluetooth connected. You'll see a steady red light on your Bluetooth module in there. And now we should be able to control this puppy. which I can hear we are doing. So there we go. So now we have the ability to test and move everything around there. There's the elbow, everything else. Turn this around here a little bit. So now that we have full control of this thing, we're going to go ahead and calibrate the gripper, because we can, finally. We're going to get a regular, small, one-prong servo horn, get a servo screw here all ready to go, and you're going to take the gripper and you're just going to close it all the way. Right there. Oops. Close it all the way. There we go. Make sure that it's not buzzing like that. You don't want it to buzz, because then it's your full extent of everything. We are also going to stick on these finger pads, because I want them to be on here. Cut yourself a sample there. Scissors. Scissors are often a lot easier than an X-Acto knife. Get yourself the pad, plug it right on there. There we are. Remove the protective tape there. There we are. Estimate the length there. Got enough for about 2 or 3 fingers in here, so if you mess up one, don't worry about it. Get it stuck on there, it should stick pretty well. Double check our gripper position. There we are. Okay, so we've got the gripper almost totally closed. You're gonna take the gripper, you're gonna close it all the way, and then you're gonna back it off just a little bit, about right there. And the reason for that is because you want to be able to compress the finger a little bit. You want to make sure you can grab really small things, because if you're just loose, you might miss out on it somehow. So now that we've got that, we're going to close the gripper. Dang near. That horn's a little bit off. Bring it out to where it'll work. Once you've got this screw in, you don't have to worry about actually using a real mounting screw to hold the servo in there, because again, it's inset there, so nothing's really going to hold against it. Let's double check that gripper one last time. Very nice. Let's bring the elbow down. Let's see if we can record a wave. I'm going to turn it this way a little bit. Record waypoint right there. Whoops. Forward waypoint right there. Forward waypoint right there. Forward waypoint. Record waypoint. And record waypoint, and now play that back. It's a little bit of a slow wave, but it's a good wave. And then he goes back to his home position there. All right, let's see here. No other little tweaks to get done, nothing else. So we can close him up. I'm gonna turn him off right, well no, actually, let's run through a couple more tests while we've got him going. So base, full extension in both directions. Good, center him right there. Shoulder all the way back, that's why you've got suckers. Shoulder all the way back and all the way forward. Perfect, so you can reach the ground right there. Then elbow, all the way forward, all the way back. Let's get him in that position right there. Rotate wrist left, right. Bring that in there a little more. Okay, bring that right there. And then wrist flex. And then all the way back. Good. And let's put that right there. And then we've got gripper. Close. Open. Medium. Cool. So the arm is working. I'm going to bring the shoulder back a little bit more because this is a nice packing position. This way you can drag him and move him around and everything else. There we go. So now we know that everything is working, everything's powered up. I'm going to unplug him here. There's the main power switch here on the other side. Drop the power cord over there. Let's see here. Remove this because I'm gonna remove the Bluetooth module because most of the time we actually use USB because on the computer software, the Windows controller for this has a lot more features to it than just the Android app. So, because the app is mainly just a demo, a way of showing, hey, this is something you can do. The app itself is made in MIT App Inventor. It's a terrible thing for development, but we set it up so that any kids or anyone who is new to app development or anything along those lines would be able to recreate it and experiment with it. So if you're interested in that thing, there'll be a whole tutorial series coming out about that. Let's see, there we are, close that up. Nice. Now, what I want to do is actually clean up some of these wires, mainly these wires along here. I don't want these big tangles out there, so I'm going to go ahead and use the wrapping here. And the wrapping, there's a trick to it. You actually start in the middle and then go out either direction. That way you don't have a whole line of stuff to have to flip around all over everything all the time. If you're wrapping this around and around and around, it gets really old really fast. So start in the middle and go out, and then you can slide it back and forth, as you'll see here in just a moment. This cleans up these wires, makes sure people don't get their hands caught in them all the time and end up tangling things and causing problems and all kinds of bad stuff that we don't want to do. Let's see here. Pull that up. There. Got this extra little coil here that I don't know what it goes to. There we go. This is when you find out how evenly you stretched out the wires. 2, 3. Almost there. There we go. Put those up into there just a little bit. There we go. Now, unplug that. Go over here. See what I mean? Having all this stuff flying around is so not handy. Especially if you had the whole arm to go around as opposed to just this little box. The reason I don't want to cut it off and trim it right now is because I don't know exactly what the length is, because the length changes depending on how thickly or closely you wind all this stuff. So I'm going for neat as opposed to fast. Let's see here, get this around. Take those little ends, make sure they're shoved into the box completely so we've got a nice clean finish here. And now we're close enough to cut that. There we go. There's that. And there we go. Get that tied off, make it look kind of nice. And there is a fully assembled and ready to operate LittleArm Big. You can go through, sometimes the 3D printing leaves a couple of strands here and there and yonder. You can whack those off, pull them off, something along those lines. It's not a big deal. They don't cause any problems, they're just there. And then you got the hot glue too that we were messing with. But get it all cleaned up and now you're ready to go. So you can, with this arm, it has the base software there that allows you to train it with either the Windows, Linux Python version of the controller, or with the Android app. All of those give you a basic programmable control. With the chip, again, you have the ability to set up sensors with it. I can't talk today. Set up all the sensors with it so you can write custom code. You can use the controllers and the original code that we had to set up and record a motion. We can then take that array of motion control commands, download them to the Arduino, and set up a simple program to rotate through them that is triggered by that sensor. So you can set up an ultrasonic sensor out here somewhere so that when somebody sets a part down in front of it, this robot arm grabs another piece and puts it into that part. So you can teach people how to build an industrial robot arm with this robot. And we'll actually add more tutorials about how to do that kind of stuff in future videos. So go ahead, guys, and subscribe down below for new videos as they come out. If there's any questions about the LittleArm Big that you have, ask them down there in comments. Otherwise, just like this video and check out some of the other videos that we have on the channel. We have a lot of stuff about Arduino, 3D printing, and robotics in general. Thanks, everybody.